In this first example, it's asking us to find f of g of x and g of f of x, where it gives us these functions, okay? And so what's different about this particular problem compared to something you may be used to is that sometimes what we've been working, we would have f of g of a number, but this time we're not plugging in a number into the function. We're just going to plug the function into the other function. Okay, so if we're looking at f of g of x, and we can already see that the answer is x, but I like to understand that, I like to rewrite it like this. It's read the same way, f of g of x, and that means the g of x is inside of the f of x. Okay, well, let's pay attention to what f of x is. F of x being x plus 10, well, f of something is something plus 10. And where do I get that from? I get that from right here, okay? F of something is something plus 10. So if f of something is something plus 10, then f of g of x must be g of x plus 10, okay? And what is g of x? G of x is x minus 10. And this simplifies down into just x. So we're going to do the same thing, and that's where we got this first answer. Now, in this case, you can already see that f of g of x and g of f of x come out to be the same thing, but now that's not always the case. So let's think about what g of f of x would be and how to calculate that. Let's see, I'll do it in a different color. So g of f of x means to put that f of x function inside of the g function. Well, the g function is x minus 10. So g of something is something minus 10. Well, if g of something is something minus 10, that means g of f of x must be f of x minus 10. And what is f of x? F of x is x plus 10. So that's where we get this answer. And so now it asks about the domain for both f of g of x and g of f of x. The domain is all reals. It's from negative infinity to positive infinity in interval notation. And that's just because it's not a rational function. We don't divide. It's not a fraction, and therefore it doesn't have a denominator that could end up being 0. So that's when we're really worried about the domain, is if there is a denominator, then we want to be sure to set that denominator not equal to 0. Well, there's not even a denominator here, so it's just from negative infinity to positive infinity. Well, let's try this one. Speaking of domain, you can already see the final answers right here. And those aren't fractions, and therefore their domains are from negative infinity to positive infinity. But anyway, we're dealing with f of g of x. So remember that f of g of x, that means to plug g of x inside of f of x. Well, f of x is something plus 3. So g of x plus 3. So what is g of x? G of x is 2x squared minus 5x minus 3 plus 3. And so that negative 3 and positive 3 end up canceling to just give you 2x squared minus 5x. And now to do g of f of x, again, I always like to rewrite it in that format, and I'm going to put f of x inside of g. Well, that g function is 2 times something squared. Okay, so pay attention to this, okay? 2 times something squared minus 5 times something minus 3. So what is that something? That something is f of x. I'll just say f of x right here. And we'll come down in a later step and write down what f of x actually is. F of x is x plus 3 So now what I need to do, I need to distribute the 2 and the 5. But before I can distribute this 2 right here, I got to get rid of that squared. I can't distribute something, so I can't distribute a 2 to something that's not simplified. And x plus 3 squared is not simplified. X plus 3 squared is also not x squared plus 9. You don't just distribute a squared to it. When you square something, you multiply it by itself. So I need to find out what x plus 3 times x plus 3 is. And we FOIL it out. So x times x is x squared. X times 3 is 3x. And now I'll say 3 times x is 3x. And 3 times 3 is 9. To get x squared plus 6x plus 9. And I'm going to put that in the place of this, okay? I'm no longer going to write x plus 3 squared. I'm going to write x squared plus 6x plus 9 because they're the same thing. So 2 times x squared plus 6x plus 9 minus 5 times x plus 3 minus 3, and now we can distribute finally. So I just distributed the 2 to the trinomial behind it, and the negative 5 to the x plus 3. So just be careful, negative 5 times that positive 3 is negative 15. And so now I'm going to combine like terms to get 2x squared plus 7x. And so that is what we get here. And again, the domain for those functions, they're not rational. There's no denominator, so they're just from negative infinity to infinity.